Okay, so this is experiment 8. We're going to look at some oxidation and reduction reactions with the halogens and displacement of metals. The very first one is a reaction between potassium bromide and chlorine water. So when you mix the two of them together, you just write down your observations, and what happens is it goes from colourless to orange. Now the reason that happens is that the bromine is formed. So here we have potassium bromide linking up with the chlorine, and we're going to get this reaction. Okay, so it's experiment 8. We're going to look at some redox reactions. The first one, experiment A, is going to be to do with halogens as oxidizing agents. So in the first experiment, we have taken potassium bromide, so KBr, reacts in a 1-to-1 ratio, so 1K, 1Br. And we're going to react that with some chlorine. And when that occurs, you can see that bromine is originally an ion because it's connected to the potassium here, and then the bromine molecule is formed. So this is our half reaction. Br minus, this minus means that it has an extra electron. When the potassium bromide separates, the bromine molecules come together and they form a new molecule. So this is our half reaction here. And we have potassium iodide solution. So there's your Ki potassium iodide. And we're going to react that with chlorine water as well. So I just have the Cl2 there. And this goes from a colourless to reddish brown, so there is a reaction happening. And we're going to look at the iodine here. So the reddish brown comes from the formation of the iodine molecule. Originally, again, we are splitting up the potassium iodide. The iodine is coming together and we're forming iodine molecule. So for that to happen, you can see that we are losing electrons, so it's going to be oxidized. As this is going to have an oxidation number of -1, this is going to have an oxidation number of 0. So we have lost electrons here. And next one, experiment C, potassium iodide and bromine water. So again, Ki bromine. The bromine is going to be the oxidizer, so it's going to oxidize this, which means the iodine is going to lose again, same thing. So where iodine is losing, oxidation number is -1, oxidation number here is 0. So it's losing electrons, forming the iodine, which is shown by the reddish brown colour that we see present in the test tube. Okay, then over here, in the next experiment, we have barium chloride and sodium sulfite. A white precipitate is formed. The HCl added in then signifies if there is sulfate or sulfite ions present. So if there are no sulfate ions present, that precipitate should dissolve in HCl. So we'll go back to clear, and that means that if there's no sulfate, there are sulfite ions present, okay? Because we do have sodium sulfite in the actual test tube. So we know there's no sulfate at the moment. So after that, we pour some sodium sulfite into the test tube of about 1/5 of the solution, add in your chlorine water, and we'll see if anything happens. So the observations are, when the barium chloride is added, we get a white precipitate, doesn't dissolve in HCl. So that means that the sulfate ion is present afterwards. Okay, so explain your observations. Sodium sulfite plus the barium chloride reacts to give us salt, barium sulfate, and water. So the chlorine has oxidized the original sulfite ion to sulfate. And we've checked that by adding in HCl. And now, because the precipitate doesn't dissolve, we can say it's sulfate rather than sulfite. Okay, so repeat the experiment with bromine water. We're just using a different oxidizing agent from the halogens. Exact same result. Here again, we are oxidizing sulfite into sulfate. So we can see it goes from sulfite to sulfate. Again, the precipitate won't dissolve. Use iodine, same as above. And there's the reaction again, sulfite to sulfate. It won't dissolve in the water, or into the HCl, apologies. Okay, experiment E. Again, we're looking at the halogens as oxidizing agent with iron this time. So we have iron sulfate. We're going to add in some chlorine, and we notice that a greenish brown precipitate is formed. So some reaction has happened. So there's also H2SO4 in the flask or in the test tube. Chlorine, iron sulfate. We get iron chloride, SO2, and water. So the iron has gone from an oxidation number of +2 to an oxidation number of +3. So iron has been oxidized. SO4 is -2, so this has to be +2. Chlorine, each one is -1, so altogether it's a -3. So iron has to balance that out with +3. So it's been oxidized. On to part B. Displacement reactions of metals. So we have copper sulfate in a test tube. We're adding some zinc in, and we see if there's any observations. The observations you should get is that zinc is covered in copper metal, and that's because zinc is a stronger oxidizer than the copper, so it's going to be reactive, more reactive than copper. This is the displacement reaction. So originally we have copper sulfate, we add in zinc. What we get is zinc sulfate and then copper on its own. So let's look at the oxidation numbers. This is the sulfate ion, which is a -2. That's your complex ion, so you need to learn that -2 off, which means for a neutral atom or molecule, we need to have a +2 here. So there's your +2. Zinc is on its own. It's going to have an oxidation number of 0. Zinc sulfate, that's -2. So it's going to have an oxidation number of +2 for zinc. Copper on its own is 0. So zinc has changed from a 0 to a +2. So it's lost electrons. So it's oxidized. Copper has gone from a +2 to 0. So it's been reduced. Down here are your half reactions. Seeing that zinc has lost 2 electrons, it's gone to zinc ++. If you want to bring that -2 across, it'll just change to a +2. Copper has received 2 electrons. It's gone from a +2 to a 0. So it's gained 2 pieces of negativity, 2 electrons. So this is the half reaction for copper. And then our last one here is G. We've got copper sulfate and we've added in some magnesium. Copper coats the magnesium ribbon. Here is our reaction: magnesium, copper sulfate, magnesium sulfate and copper. 0 oxidation number for magnesium, +2 for copper, +2 for magnesium then, and 0 for copper. So we've gone from 0 to +2, so it has lost electrons. It's become more positive. So it's been oxidized. Copper has gained electrons. It's gone from a +2 to a 0. It's gained some negativity, so it's been reduced. That's it for that experiment.